So we just saw a resolution derivation of a clause phi from a set delta of clauses is a sequence of clauses terminating in phi in which each item is either a member of delta or the result of applying resolution to earlier items. Now we define a sentence phi to be provable from a set of sentences delta by resolution if and only if there's a derivation of the empty clause from the clausal form of delta together with the negation of phi. Resolution proof is defined to be the derivation of the empty clause from the clausal form of the premises and that negation. As an example, let's consider a case we saw earlier. Right, the premises are shown here. We know that everybody loves somebody, and everybody loves a lover. Our goal is to show that everybody loves everybody. In order to do that, we negate this conclusion and add it to our set of premises. Okay, now we convert to clausal form, leading to the clauses shown below. Note that we have a Skolem function in the first clause, and we use a Skolem constant, actually two Skolem constants in the last, one for x, one for y. Okay, now in order to prove the result, we write down these clauses and apply resolution. Resolve the first clause with the clause on line 2 to produce the clause on line 4. Here v is bound to x, and w is bound to f of x. Since w doesn't occur in the second literal of the clause on line 2, it just disappears, and u has no binding, so it remains u. We end up with the clause loves of u x. And now, in the next step, we resolve the clause in line 4 with the clause in line 3 to produce the empty clause, and thus prove our result. Okay, now let's look at a more interesting case. Let's once again consider the problem of horses and dogs that we saw in an earlier lesson. We know that every horse is faster than every dog. Some greyhounds are faster than every rabbit. We know that greyhounds are dogs, and we know that the relationship of being faster is transitive. And what we desire is to prove that horses are faster than rabbits. In order to do this, we negate that desired conclusion, and we add it to the premise set. Okay, now we have to convert the premises to clausal form, and that's done as shown here. First sentence leads to a single clause. The second sentence leads to two clauses. This is actually the case we saw earlier in the conversion to clausal form. We have g of Greg and the clause consisting not r of z and f of Greg z. The third sentence leads to a single clause, and the final sentence also leads to a single clause. Okay, now our negated goal is a little more complicated. We have to push that negation through the universal quantifiers. And we need to add Skolem constants for the existential quantifiers that result from that distribution. In this case, we use Harry and Ralph, assuming that those words are not already in our language. Okay, now we have our clauses. All we have to do is go to work with resolution. So first we resolve the clause on line 2 with the clause on line 4 to derive the fact that Greg is a dog. Y bound to Greg. We resolve the clause on line 6 with the clause on line 1 to derive the clause on line 10. And we resolve these two results to derive the fact that Harry is faster than Greg. Okay, next we resolve the clause on line 7 with the clause on line 3 to derive the fact that Greg is faster than Ralph. At this point, all we need to do is use transitivity and we're done. So we would first resolve the clause on line 11, with the transitivity clause on line 5. We get this intermediate result on line 13. And then we resolve the clause in line 12 with this intermediate result to derive the fact that Harry is faster than Ralph. Not quite done yet because we still need to get the empty clause, but that's easy. We just resolve the result on line 14 with a negated goal clause in line 8 to derive the empty clause. Okay, this example shows that resolution is somewhat more focused than Fitch. And the added good news is that it's really every bit as powerful. In fact, it's possible to derive a conclusion from a set of premises using resolution. It's possible to prove a set of premises using resolution if and only if it's possible to prove that conclusion using Fitch. Or I should say, Fitch without the domain closure rule for finite domains. It's possible to extend resolution to cover domain closure as well, but we haven't talked about that here. We'll see that in a later lesson.